to our screen. Let me share my screen again. And here's our exercise. Okay. So now one thing that I would like to do is to actually simulate this system. Okay. So question, let's say example. Now how do you simulate this system, right? Now obviously one way you can do this is to go in MATLAB and investigate, nonlinear differential equation solvers. There are many different numerical methods there and many tools that you can simulate this system. But what I will do is I will try to simulate this, okay, manually, okay, to show you basically basic principles of how you can do this. Okay, so let's say we make some assignments to our variables. Let's say a is equal to 1. Q in of t is equal to 1 for t larger than or equal to 0. That means it's a unit step basically. Let's also say that the combined constants a to square root of g is also equal to 1, which is kind of a simplifying assumption. So what we are asking is that simulate this system for h0, h at 0 is equal to 0 and h at 0 is equal to 2. Okay, so two different initial conditions. Two different initial conditions. Now obviously you cannot transform this into a transfer function, so you cannot use basic linear tools such as the step response in MATLAB. If you want to use MATLAB, you really need to go to the differential equation solver in order to simulate this. The way we will try to do this, so our simplified differential equation is dh of t over dt, because of our given values, is plus square root of h of t is equal to 1. Okay, so this is our differential equation with the given numerical values. The simplest way to do this, the simplest way to simulate this system is to discretize it in time. That means make it a discrete time system using the Newton's formula. That means I'm gonna assume the simplest approximation to the derivative that we had discussed before, right? So we have h at time k minus h at time k minus 1 divided by delta t. Previously we had called this capital T. I'm writing, by the way, but nothing is appearing on your screen. It's gonna come in, I hope. Where is my screen? Arkadaşlar herhangi bir şey görüyor musunuz siz? hk minus 1 divided by delta t. Now
Şimdi geldi hocam.
Gördüm, evet. Plus square root of hk minus 1 is equal to 1. Let's also assume delta t is, let's say, 0.2 seconds. Okay. Now, if we rearrange this, we can actually...
K yerine niye HK minus 1'ı kök içine aldık?
Neden aldık? Çünkü diferansiyel denklemimizde öyle.
Ama T'yi K olarak şey yapmıyor muyuz? Çünkü diğerinde Yani k-1 mi o t'deki an? Öyle mi?
Öyle varsayıyoruz causal bir yapı olsun diye. Aksi takdirde non-causal bir yapı oluyor. Yani burada her şeyi
K'da
bir
olsa
kaydırmak.
gene kontrol oluyor.
K'da olsaydı bir sıkıntı yaşayacaktık. Çünkü biraz sonra göstereceğim şekilde biz bunu hesaplanabilir bir nümerik bir formül haline getirmeye çalışıyoruz. Ve causal bir şey haline getirmeye çalışıyoruz. Nedir bu? Yani yani h'in bir sonraki andaki değerini önceki andaki değerlerinden hesaplamak istiyoruz.
Şey gibi değil mi? Bu K'lar çok yakın olduğu için K'da,
Aynen
K-1'de
öyle.
de
Delta
varsa
T çok küçük ve dolayısıyla K'lar aslında birbirine yakın değil. K'lar integer. Ama delta T küçüldükçe K ile K-1 anındaki seçilen anlardaki h'in değerleri birbirine çok yakın hale geliyor. Dolayısıyla h of k veya h of k-1 almak o kadar önemli hale gelmiyor yani. Giderek önemsizleşiyor. Delta t sıfıra doğru giderken hiçbir önemi kalmıyor. Continuous bir formül için. Ve burada edindiğimiz avantaj şu. Now, we can write hk now in terms of other things in k minus first instant. Okay? So I'm going to have hk equals to hk minus 1 plus 0.2 minus 0.2 times square root of hk minus 1. Okay, so what you see here is that I'm writing h at time k in terms of its values at the previous time. Okay, so we can call this a recursive computational formula. Computational formula. Okay. Arkadaşlar bundan sonra dersiniz var mı?
Hocam benim bitirme toplantısı var hocam.
Bitirme
dersim var hocam.
Sonra da ders var. Okay. So up next, okay, and that's gonna have to wait for next week in this case. But you can actually attempt yourself, okay? What we will do is do something like this, right? We will say, we will start with k is equal to 0, and we will continue with future times, okay? And what we will do is we will obviously start with hk. So we will start with h at k is equal to 0, okay? We have two instances. We will first start with h at k being 0 and hk being 2. And simply calculate what's going to be the value of hk at future time instances using this formula, okay? Use the formula to compute future values of h at time k and plot, okay? So this is a simulation, because what we are doing is we generated a numerical formula which allows us to calculate the future value of h from previous values of h, and we can do this successively for every successive value of k. Okay, so this is a discrete time. So it's a discrete time approximation to the ordinary to the differential equation with continuous time. And it becomes accurate if delta t is very small. Okay? Peki arkadaşlar, burada bitirelim. Önümüzdeki hafta görüşmek üzere. Sorusu olan, sormak isteyen varsa kalabilir. Çıkmak isteyen çıkabilir.